Today we are going to talk about law of sines and using the SAS area conjecture to find the area of non-right triangles. So we're going to skip ahead because this is going to be the abridged version. We are going to do the examples, however I want to do the formula first. So please flip ahead until you reach the SAS triangle area conjecture in section 12.4. This is a formula that can find the area of a triangle when you do not have the height, but you have the base and a side and the included angle between the base and the side. So all you have to do is you take the A value, which is the base in this case, multiply by the B value, which is a side of the triangle, and then we're going to multiply by the sine of the angle that is between those two sides, and then because it's a triangle, divide by 2. So what's really happening is when we have this sine of C part here, it's going to help us figure out the height. So we're going to be using that all to create the area of the triangle. So we're going to use this formula to try some of the example problems. Alright, so I'm going back to example 2 in this section. And if I look at my formula, it says take your A side times your B side. It doesn't really matter which one you call which. So I'm just going to call the A one down here like it was in the example formula. And the 29 I'll call my B side. The angle, that is angle C, has to be between those two sides. So the 55 is smack between these two sides here. So this is going to be angle C. And then I just need to plug in my values. So 33 times my B side is 29 times sine of my angle, which is the 55 degrees. And remember to make sure that your calculator is in that degree mode. And then finally, divide by 2. So if I go over to my calculator and I punch this in, I already checked that my mode was in degrees. I'm going to do 33 times 29 times sine of 55, close my parenthesis, divide by 2. So the area of this triangle, how much space it is taking up, is approximately 392 square centimeters. And I'm writing with a mouse today, so forgive me for my terrible handwriting. And that's all there is to it, to finding the area of a triangle when you have two sides and the included angle. So next we're going to skip ahead to another formula called law of sines. Alright, so on this page we've got the formula down in the box here, and it says for a triangle with angles A, B, and C and sides of lengths little a, little b, and little c, where they are opposite of each other's corresponding letter, then we can use this formula. There's a couple different ways to write it. Looks kind of complex because there's 3 radicals, or 3 ratios, but it's okay. We take the angle and place it in the sine function, and we place the opposite side underneath it. So notice angle A is across from little a, angle B is across from little b, and angle C is across from little c. Now the top formula here has the sine functions on top. The bottom formula has the sine functions on the bottom. It doesn't matter which way you go with, you just have to be consistent. Okay, now notice this again is not a right triangle, yet we are going to be able to use trigonometry to find a missing side length. So let's say that you were given one side length and two angles. You can use this formula law of sines to find the missing piece. So I'm going to go down to this problem example 5, and I'll try typing this one to see if we can get some better results here. But it says, find the length of side AC. So if I highlight side AC, that is in reference to our little b letter here. So we are missing a side length. However, we have the angle across from that side length already. So notice this is capital B and little b. And we also have another angle, capital A, which is across from side 350. So this we're going to call little a. We are not using angle C or side C. So we do not need those two pieces. So since we are just using A and B, I am going to use the two fractions that include A and B. So I can either set it up with the signs on top or the signs on the bottom, but those are the equations I'm going to use. Alright, so starting off with my formula, I'm going to do sine of my angle A, which is 59. And then underneath that, I'm going to put the side length, little a, which is 350. Equals, my next fraction is going to be angle B's information. And across from that, little b, which I don't know, oops, I made a mistake. I don't want the big B sign, I want the 38 degrees. And then across from that is little b. So now that we have this set up, it's just a matter of cross multiplying. So I'm going to take 350 and multiply by sine of 38, and then we are going to be dividing by the leftover part, and that leftover part is sine of 59. So divide by sine 59, and this is going to get us the side length for side B. So if I go over to my calculator, 350 times sine of 38. I have to make sure I close my parenthesis before I do the divide. Sine 59. And this answer comes out to be about 251. Oops. So that means side B is about 251 centimeters long. Alright, so your assignment for today is completing this section on Schoology. Again, this is section 12.3, Law of Sines. You have two formulas that you can use for completing the problems. Using the law of sines can be a little difficult, so just take your time, collaborate with each other, and we can answer questions on Monday.